PaaS overview. In this section, we will look at platform as a service. So what are the objectives of this particular section? We will first define what a platform is. Then we will describe the various platform services that may be attached to a platform. And then we will define platform as a service, which is what PaaS is all about. We'll look at the benefits of PaaS and also the drawbacks of PaaS. Before we get into what a software platform is, let's define what a platform is. Here we see a picture of Cape Canaveral where you see a platform, a big platform that has become the launching pad for the product, which is really your rocket, right? So the platform is really all the plumbing that's necessary to launch your product, in this particular case, the rocket. In the same way, a software platform is all the plumbing that's necessary to launch your product, which is your software application. So what is a software platform? A software platform is a piece of software that provides several services so that the application developers can concentrate on the business logic rather than all the plumbing, rather than all the platform facilities or platform services. So a software platform is really a combination of an application server platform, which we will define in a few seconds, plus platform services, which are all the services that are built on top of the server platform in order for you to write your applications. So what is an application server platform? An application server platform is also known as middleware. It's a software framework that provides mechanism to create applications. Now, it may be to create web applications or non-web applications. It is also a server environment where your applications can be deployed and run. It also has a comprehensive service layer model. There may be the presentation layer, the business logic layer, the data access layer. The middleware or the application server provides lifecycle, pooling, naming, transaction, and security services for the various components. When I say lifecycle, launching the object, instantiating the object, invoking methods on the object. Pooling is your object pooling. Naming is some kind of a naming service so you can retrieve an object. Transaction services, which is your database transactions or two-phase commit transactions. Security services, which is your web application security or business logic security. Using an application framework, the developers write components and they actually use the API that is available as part of the platform. And these components run inside the application server. The application server also separates the client tier, which could be your desktop or your mobile devices, from the application and the data source. So really the application server is separating the user interface and the presentation logic from the data source. So that's how you get the three tiers. What are some of the examples of an application server platform? Java EE is a classic example of an application server platform. The application server provides mechanism for you to build your presentation logic, such as servlets, JSP. It allows you to build your business logic using entity beans and session beans. There are also several application server or platform services like messaging services, database services like JDBC, naming services such as JNDI, transactional services. There's also communication services such as TCP/IP, HTTP, SSL, RMI, which is remote method invocation. So Java EE is an application server where application developers can write their applications and deploy into the platform. There are also other platforms, other application server platforms. There is the .NET C# platform, Node.js JavaScript platform, Ruby on Rails Passenger platform, PHP Zend, Python, Django Flask, Google Go, Vertex, Java, JavaScript, Groovy, Ruby platforms. So there are different application servers, application software development platforms, and the various actual server software that allows you to run those applications. So what are the various platform services that may be available in an application server platform? The application server platform actually integrates several services in order to simplify the application development and also the deployment of the software and also ability to scale the applications. The various platform services include relational databases, NoSQL databases, big data analytics, queuing, caching, content delivery network, notification, monitoring, DevOps tools, and so on and so forth. So let's go ahead and look at each one of these things in a little bit more detail. An application server may provide mechanism for you to connect to a relational database so you can get relational data persistence for your applications and also transactions for your applications. Examples of relational databases are MySQL, Postgres, Oracle, SQL Server, DB2, among many. And of course, you create your entity and relationships using the ER diagram, and all the entities and relationships are stored in the database table, which is your database software. NoSQL databases provide a mechanism for storage and retrieval of data that cannot be modeled as relational. And so as part of NoSQL databases, you have key value based databases, document based databases, graph based databases, column oriented databases. Now these are just some of the top NoSQL databases. There are many other kinds of NoSQL databases that are available. NoSQL is a big topic on its own, but I just wanted to tell you that an application server or an application developer that's using an application server may want to integrate with NoSQL databases in order to store non-relational data for their application. Examples of software services for NoSQL databases are MongoDB, HBase, Cassandra, and DocumentDB. These are some of the top ones. And by the way, when people say NoSQL, some people also refer to it as not only SQL. In other words, it's beyond SQL. There is also big data analytics. When you're building your application, there might be a lot of data. Now, the lot of data may be because of this volume of data or the speed at which the data is coming in or different data sources, which is the variety of data. All those things lead to what is called data complexity or big data. And you might need mechanisms for you to process that data. Hadoop, Pig, Hive, Spark, Tableau, Splunk are classic examples of big data analytics software platforms. Many times your application requires asynchronous business processing. So you need services that allows you to put messages into some kind of a queue which can be processed asynchronously. What you're seeing here is a queue, and you have clients or senders that are putting messages into the queue. Those messages are being picked up asynchronously by receivers, which will process the messages by popping the messages off the queue. There are many software services that allow you to do queuing. For example, there's JMS, Java Message Service, Microsoft MQ, MSMQ, RabbitMQ, ZeroMQ, SonicMQ are all classic examples of queuing systems and queuing services. Caching. Caching service is a service that allows you to store data in a cache for later retrieval. It is primarily used for performance. For example, your application server or your application logic may want to connect to a database, read the record, and then store the record in a cache so that the next time the user asks for the same data, you would actually retrieve it from the cache and give it back to the client. And then you would actually go back to the original database, to the original source, only if the cache is invalidated or the cache has timed out. There are several services that are available that allow you to do caching. For example, Memcache and Reddish are classic examples of caching services that may be needed for an application server. There is also Content Delivery Network, also called CDNs. CDN is a service that delivers web pages and other web content to a user based upon geography. So if a user is in Japan, then you want to give them web pages and images and audio and media files much faster by distributing the data to those different geographical locations so that they can get the data from the local servers. CDNs actually provide such services. Akamai and Limelight networks are classic examples of CDN providers. As you can see, over here you have clients all over the world that are coming to the original source of data to get the content. Everybody is coming to the original source. With CDN, you can have the original source somewhere in the middle, and then you can distribute the data to all these different CDN servers, and then the clients connect to their local CDN server to get the data. So it's a distributed content delivery network. Notification. Notification is a service that allows sending notification through email or SMS gateway. Sometimes in your application, you want to send an email message to your clients or to your customers, or maybe you want to process email messages from your customers, or you may want to send notification text messages to your customers. The notification service provides you such capabilities. Twilio allows you to send text messages. It's a very popular notification service. There's also Google Gmail. You can interface with Google Gmail, which is a mail service. Same for Microsoft Live and Yahoo Mail. Monitoring. Many times in your application, you want to monitor your application, you want to monitor your infrastructure, so you need a service that allows you to hook triggers into your infrastructure and your applications so you can monitor them and send alert messages. Classic examples of products and services that do monitoring are Nagios, Hyperic, and Op Manager. DevOps services. Today, DevOps has become a very popular term. There are several tools that are popping up in helping us build, test, develop in a fast-paced IT environment. Not only develop, but also deploy, I should say. Source code management with GitHub, continuous integration with Jenkins, or automated deployment with Puppet and Chef Ansibles are all classic examples of services that allow you to do DevOps management. So you can continuously code, build, test, deploy, operate the application, monitor it, and then make changes to the software so you can keep on going in this infinite cycle, which is what we call DevOps services. And there are several software services that are available for you to do this. There are also other miscellaneous services. For example, there is the transcoding multimedia. For example, you can take a .tiff file and transcode it to .gif or .png, or you can take a .mov, which is a movie file, and convert it into .mp4 or some other format. So there are some services that are available that allow you to do transcoding. There are also services that allow you to do language translation, so you can translate from one language to the other. So the point I'm trying to make is there are several services that are available on top of the application server for you to build your applications. And this is exactly what we do in a traditional enterprise. We bring in our application server, then we bring in all these different services that are built on top of the application server so that we can build our application. What if we have an environment where the application server platform and the platform services are all available as a managed service to us as the developer or to us as the enterprise? If that can happen, that's what we call PaaS, which is platform as a service. The idea here is rather than us worrying about the infrastructure and all the platform application server and application server software services, we only worry about our software and get the application server as a managed service. So PaaS is really in the middle of the stack. If you think about it, there is the hardware. On top of the hardware, there was IaaS, which is infrastructure as a service. And we actually looked at several infrastructure as a service, for example, compute, storage, network, resources, physical, virtualization, all kinds of different things we looked at in terms of infrastructure as a service. Now what we're saying is, what if we have an environment called PaaS, which allows us to concentrate on our business logic because it provides a programming and a runtime environment for us to deploy and run our applications. And so that's what PaaS is all about. You've seen this picture before. We saw this thing for infrastructure as a service. Now let's look at the same picture as a platform as a service. If you think about packaged software, in packaged software, they do it all for you. They give you everything from hardware, from networking, to storage, to servers, to all the way to applications. And then we looked at infrastructure as a service. In infrastructure service, we get the hardware, the networking, the storage, the servers, and virtualization. And all we have to do is select the operating system, the middleware, the runtime, data, and applications, which is what we did up to this particular point in this class. Now what we are saying is, let's move one level up on the layer, which is platform as a service. Now let the vendor or the cloud provider manage the networking, the storage, the servers, the virtualization, the OS, the middleware, and the runtime environment, so that we can concentrate on our business logic and we simply deploy our applications into these managed application server platforms. So what is the motivation? The motivation is to reduce administration cost. We don't have to worry about any application server management. We don't have to worry about installing, configuring an application server. There is also increased flexibility. We can bring in a smaller version of the application server, a larger version of the application server. We can bring in multiple versions of it. Very flexible environments. There's also improved scalability. The application server environments are in a cloud environment, so it can scale, auto scale up or down. There is also a reduction in development effort because we don't have to use our developers to build environments. They're already built for us at the point of a click of a button. There is also increased availability. We can use all the capabilities that are there in the cloud environment, distributed computing environment, distributed machines, auto scale, launching machines on the fly to improve availability of our system. We can also get to market very fast because of the reduced time. There is also reduce the overall costs because now we don't really have to buy all the hardware and all the application server licenses until we get our customers. We can also focus on business applications rather than the infrastructure, and also it reduces the fixed costs. We can start small and grow big as the customers increase in our system. So let's compare PaaS to pizza. You've seen this diagram before. We looked at this diagram when we talked about infrastructure as a service. If you think about the traditional model where pizza is made at home, where what you do is you get your own cheese, your own toppings, tomato sauce, pizza dough, fire, oven, electric gas, soda, and the dining table. You bring it all yourselves, and then you make the pizza at home. Versus in infrastructure as a service, that's the take and bake up model where you buy the cheese, the toppings, the tomato sauce, and the pizza dough, but then you have your own fire, oven, electric gas, soda, and dining table. You bake the pizza and then you eat the pizza. In the platform as a service model, it's the pizza delivered model where the cheese, the toppings, the tomato sauce, the pizza dough, the fire, oven, electric gas is all outsourced, and what you really get is the pizza, which is delivered to you, and you sit down in the comfort of your home on your dining table and you eat your pizza, drink your soda. Then there's the software as a service model, which is really your dining out model. What we're really talking about right now is platform as a service, where the pizza is being delivered to us. All we have to do is eat the pizza, but we have to bring in our own dining table and our own soda. So what are the benefits with the PaaS model? Dynamic allocation of environment and scaling the environments. We can launch our services on a small section and then we can scale it to the entire world. There is also quick development. You don't have to worry about creating your own environment. You can just outsource that, get a managed environment. Allows you to build test environments very fast, also deployment environments, and scale the deployment environments. So the dev teams can try different configurations also. They can try multiple machines, single machine configuration, run stress tests, performance, capability, all kinds of things can be done. You don't have to really wait for the environments. It can be launched very quickly. The application server environment can be launched very quickly. That's the real idea behind the PaaS model. And all we worry about is the business logic, deploy it, test our code. And so there is increased focus on the business. The companies no longer need to expend efforts on the maintenance and choice of systems. They only have to worry about the business logic. What are the drawbacks with the PaaS model? Data security is a big concern with the PaaS model. With the cloud model, the security is a very important aspect of it, and people are always concerned about security. But with PaaS model, it's even more, because now not only do you have the infrastructure, you also have the application server, and applications are the ones that manage the data. And so you have to be a little bit more careful, and you're more wary of, hey, what is really happening under the hood, under the hood inside the application server. So data security is a key factor, very important factor when it comes to PaaS. So it's a big drawback. Programming models. Some of the application servers may give you a programming model which is a proprietary programming paradigm, and so there might be some issues with vendor lock-ins. There is also limited flexibility. The PaaS solutions can't match the flexibility of an IaaS where you're doing everything. Remember, in an IaaS, you have complete control of your environment, of your infrastructure. Here, you may lose some flexibility. There may also be problems integrating with in-house systems and applications when you're especially going into a cloud-based PaaS model. In summary, we defined a platform, especially software platform, to be a piece of software with built-in services to ease development. We defined platform services as various services that the application server works in conjunction with in order for us to get persistence, queuing, notification, monitoring, logging, and other services, including DevOps services. There is also platform as a service, which is really a managed application platform with supporting services. When we say managed application platform, it's a platform that's available in the cloud. The cloud provider is automatically giving all these platforms built on top of the IaaS platform. There are several benefits to PaaS: quick development, testing, and deployment, because you can launch environments very quickly. You can scale the environments very quickly. So there is increased focus on your business. But there are some drawbacks of PaaS, which is data security, vendor lock-in, limited flexibility, and some integration problems. Here's a Dilbert cartoon on PaaS. Spend about 30 seconds and enjoy the comic strip. That was PaaS, platform as a service.